This is the raw data from the parallel plate showing sample inflation with time. Each color and F number corresponds to crystal fraction in volume percent. To begin, we use the crystal-free sample F0 as a benchmark for vesiculation, undampened by crystals which vertically expanded about 40 to 50% of its minimum height. The bars on the right represent ranges of inflation for crystal-bearing samples normalized for the glass content, since of course melt and bubbles are changing volume, not the crystals themselves. In other words, these bars represent the expected range of inflation for each crystal content. And we can divide this plot into two segments. In the lower portion of the figure, we can see the crystal-rich analogs F70 and F80 saw little change in height due to bubble growth. As a result, their anticipated height change was overestimated. F60 was closer, but was overestimated as well. The point at which sample growth terminated is interpreted as the point when permeable outgassing was achieved. Samples were then quenched at this point, and although open system degassing might have continued, the termination of growth signals an efficient release of overpressure. Therefore, our samples preserved their porosity and pathway geometries that facilitated permeable outgassing. If we move to the upper portion of the inflation diagram, you'll notice F50, the 50% crystalline samples, far exceeded anticipated values by up to 26%, and in one case nearly overcame the crystal-free analog. Prior studies have stated, at least for crystal fractions less than 0.4, that the presence of crystals impede isolated spherical bubble growth and promote distortion. This in turn facilitates bubble coalescence and earlier outgassing. Coalescence, however, requires ease of ductile flow within the surrounding melt to occur.